So we're going to do this, as I say, a very open discussion. I will, in a moment, ask, first of all, I'll do a little introduction. I ask your indulgence with that, but I'll ask for a short introduction just in terms of identify yourselves and tell us what you do. I think the audience is familiar with a couple of the presenters already, so we'll keep that simple, and then we'll go into a range of discussion points. So it's been a very interesting discussion about big data, and walking into the room, I had before the conference, I had a kind of a notion about what I thought big data meant, and I guess we all did, and I think I heard 4 or 5 different sort of ways to look at it, or definitions as we went. And I got to thinking about my first exposure to what I thought was big data, which was when I was in graduate school, this huge stack of punched cards. It was the most data I'd ever seen. And I went into the data center and I dropped them. And I didn't know whether they were numbered or not, so I was tempted, because I would flunk if I didn't get this right, this particular course. I was tempted to run them in a randomized fashion, which really would have been big data, because I didn't know what order they were supposed to be in, and just let the data speak for itself. But fortunately, the person who ran the data actually did number the cards, so I was okay. So my second exposure to big data was when I started working with thinking machines. And they were working on what became data mining, or they eventually called data mining. But they looked at me and they said, well, you know, there's no hypothesis involved in looking at this data. There's no presumption that we make, because the data has to speak for itself, and no human could understand the pattern that may emerge, so we don't tell it anything, and that's what the algorithm does. It looks for those things. And so that's a little different from what we've always done in HPC. It's a way to look at it. That got me thinking that there are 3 or 4 different ways to think about big data, and I want to talk about how to apply it to HPC. 1, you can store data, retrieve it, and then restream it someplace and take a look at it. You can store it, analyze it with a hypothesis, test it against some model. You can store it and analyze it with no hypothesis and run it and see what the patterns in the data tell you. You can never write or store it and just look at it as it goes by, streams through memory, and hope for an instant quick analysis and get some reduction out of it. Or you can never write it, never analyze it, never look at it, never read it. So there's lots of different ways to look at this. So one of the things I wanted to do was start with the panel and ask them, okay, so we have a new rule now that everybody who comes and talks about big data has to define it. So, so in HPC terms, when you think about all the different ways you can think about it, our traditional way in supercomputing of thinking about things is running large data sets against a model and using those traditional, I won't call them legacy applications, to yield some results. So after all this discussion, how do we think about or define what HPC means, what big data means to HPC as we traditionally define it in this room? You want to start out, Stephen?
Sure.
Again, a brief introduction if you'd like.
All right. So anyway, Stephen Wheat with Intel Corporation. So big data as it means to HPC. Earlier, I think I saw one of the best summaries of that is that it's a TAM expansion, or if you will, what we refer to as total available market expansion opportunity for HPC. A new usage model is emerging, and as people are becoming aware of potential, and we certainly saw this, just because you have data doesn't mean you have information, potential differentiation from mining and either finding the relationship, as we saw earlier in Addison's talk, between the straw or the needle in the haystack kind of thing. So all the things that we saw earlier. It's an opportunity for those that are seeking differentiation to apply a technology that has been, if you will, in our traditional space of being able to do significant amount of computation of whether it be comparison or computation or whatever, that skill sets that are there in the means to assess data in the forms of the big data we're traditionally about in new data realms. And so to me, it's the big data that's coming along is it's gotten beyond the intuition of the various different amounts of or types of data that are coming into various enterprises, and they're finding that there's this group of people over here that have skills and technologies that, combined with those data sets, can develop solutions to actually look at that in a way that they hadn't before or couldn't have even thought about before. So to me, it's a way of seeing an increased usage of HPC technology in a new usage domain.
So I'm Sanjay Umarji. I'm with HP's Big Data Competency Center. And I couldn't agree more with Steven here, because if you see big data, and you are all from the HPC area, I mean, you always were doing big data. I mean, why suddenly a new term has come up? And effectively what has happened is new techniques have emerged from that. So I see this area more as converging now. A lot of techniques will merge into that. This morning we heard about from HGI about the weather and how they can bring the resolution down. And as you bring the resolution down to 25 meters for weather prediction, the data became large. So this goes back to the classic definition of big data, which is the volume, variety, and velocity. And that's how I would describe it.
Rene?
Yeah, I'm Rene Copeland. I'm with Silicon Graphics, the federal part of Silicon Graphics, and we deal with sales into the federal government. I wouldn't disagree with any of the definitions that have been posed, but would say that since this is about HPC and big data, at one point we would spend a lot of time defining, what's a supercomputer, and some of the definitions that emerged were things like anything that cost $10 million, which didn't hold for very long, or any machine that was designed by Seymour Cray, and that too was something that had its run and didn't hold permanently. But I think a guy named Neil Lincoln had a definition that when something like a supercomputer is the machine that's only one generation behind the one that you really need. So and I can't exactly apply that to big data, but I think when the volume, the variety, the velocity, et cetera, starts to exceed the capabilities of the equipment that you have, you're starting to get into that big data realm. And when you're trying to find insights that are not intuitive, you're starting to get into that big data realm. And I would maybe caveat that just a bit with the comment that Addison made in his presentation, is that it's relative. The big and big data is relative, the high and high performance computing is relative. So it would be possible also to have entry level, big data kinds of opportunities. And then maybe finally, we've been spending some time looking at things by market. So I think big data could easily vary by the markets. We deal in the financial market. The big data there might be totally different than what we're seeing in the internet market versus what we're seeing up at Fort Meade, which has been referenced a lot of times. So some variability in there, but finally would say that if you define it too tightly, you may kind of put yourself in a box. I think just leaving it a little bit loose allows you to pursue big data activities without the hindrance of having to make sure it fits a very distinct classification.
Devin?
Devin Jensen. I'm, like Bob, a virtual VP. Get to work from home. Altair has about 1,800 around the world, but a third of them at headquarters in Michigan. But I think my first exposure to big data was the last couple years at Intel, foraging into the world of high-performance computing, and then at Linux Networks for a couple of years with Rene. And since then, my definition has really been around large data sets. We heard this as one of the first points that Dr. Go made this morning. I think David Bowen did a great job making that point, that as soon as the resources are available, as soon as you can support larger data sets and everything, that's where they'll go. They have the simulations ready to do that, so it's something that grows to fit the availability.
Okay. So traditionally in this room, and I don't know, some of you have been here many times, but over the years, the discussions in this room have really centered on really high-end computing, supercomputing, new architectures, where we're going, looking to the future. And there's been a certain tone underneath that, I must admit. And the term embarrassingly parallel was only used once in this conference, but part of that tone is that just because something is massively parallel and just because there's lots of, maybe some message passing and lots of processors, doesn't really make it supercomputing or as legitimate as it might be in terms of grand challenge computing or some of the things that have traditionally shaped the market. So in that sense, why is big data analysis or analytics HPC and not just a good place to park some parallelism? Why is it supercomputing? Why in this environment is it legitimate that way? Stephen's reaching for a microphone.
No. Takers? So I think there's a presumption that says that, to be, I don't know.
Let me add one caveat, and that is that I'm talking about the group of people that you would find at supercomputing, right?
Well, we for a long time have been trying to explain that while we try to aim and facilitate the most capable platforms on the planet, that it takes an entire community and ecosystem to support that. There's just no amount of government funding that can bring about a specialty machine that's just not tied to the rest of the economy. And so supercomputing is in a continuum of HPC all the way down to the workstation. And so, whether the most valuable big data problem out there, regardless of which version of big data it is, valued by whether human life or money to be made because of the insight or anything along those lines, actually required you to be at the pinnacle of HPC or a third of the way down, is perhaps at a system that's just as powerful in flops or in bytes per second in fabric as that high-end supercomputer, seems to be kind of a distracting kind of question. So I'd say that the relation of whether it's supercomputing or not is kind of silly. The question is, do I need to build that same high-end system to do the worst, most difficult big data problem? And the answer to that is perhaps not. But could there be a big data problem that is suited for that big system? Absolutely. I think it's a continuum across the space. But which one's going to be more valuable to humanity to have had been solved? It could very well be a capacity system that is disdainfully looked at as an embarrassingly parallel system.
Yeah, I think also big data has been associated with the supercomputing world for a long time, and maybe there's just an assumption that if you're going to solve problems of that class, it would be the same people that are dealing in supercomputing that would help you solve those problems. We have a slide somewhere in our company that goes back to 1996 at the supercomputing show, and in that show there's a picture of the SGI booth. And there are three big signs up, and one says big viz, or big visualization, big compute, and big data. Now, we clearly didn't know what we were talking about when we put the sign up. It probably just meant storage or petabytes or probably gigabytes or something at that time. But there was that association with that market segment, however you defined it, in the supercomputing world that's kind of been on and off, I think, for many years now. And just of late, I think big data has become, sort of popular, and, the layman's picked it up, and it just sort of seems like that association is held. And I think, therefore, it's sort of associated now with supercomputing.
If it runs on a supercomputer, it's a supercomputer problem. And one definition that has stuck with me over the years is where you push the boundaries just beyond where they work really well. And it's our job to keep that hanging together, but that works with big data.
Sanjay, do you want to chime in or on this one? So let me direct a question a little bit more your way. So once again, I've been here a number of times in this environment, and there are a lot of data management companies out there. You and I talked about this a little bit that are never mentioned in this room. I mean, it seems to me that there's a Venn diagram out there right now that's got two big circles that don't intersect, and one is the conversation of the supercomputing, the SC12, SC13 crowd, and the data management crowd. So you've got, I mentioned to you, Dr. Michael Stonebreaker and all the companies that he has founded. How many are familiar with Dr. Stonebreaker? Well, these names, Oracle, Teradata, you can Streambase, you can go in a long list of companies that are looking at different ways of both emerging companies that are looking at different ways of analyzing data and well-established ones. But that conversation hasn't been a supercomputer conversation. So tell us a little bit about those technologies and how they intersect with HPC.
Okay, I think it's a great question. If you see Dr. Stonebreaker designed Ingress, some of you may be aware of that. And then he went on and developed what is called as a columnar databases. So columnar databases is traditionally we look at row and column as the relational database. The columnar database is organized by column. So if you look at the database of all the people, location in this room, and you can see that we all are in the state of Rhode Island, city of Newport, and on this street and this address, and then maybe our social security number, which points us to unique that. Now think about it, this as a row in a traditional database. It's stored now for every one of us. These first 20-30 bytes are going to be repeated in terms of storage. Now think differently. If I transpose this row, now I just need the first 30 bytes stored only once, and then all the social security numbers pointing to those 30 bytes. So now I reduce my storage, if there are 50 people in this room, almost by that much amount, significantly. So what has happened is, in the analytics phase, as they started from the commercial area, the relational databases were not able to handle the volume as the volume grew up, because of the storage not being cheap a few years ago. And that's where some of this columnar technology came into play, because they can compress the data almost 50 times, 60 times. And that sort of created a huge economical value proposition that allowed that. And keep in mind, this is not just storage proposition, right? Look at the queries now. If I'm querying by a specific thing, I'm reading less data off the disk. So that itself improves significantly large. And that's how the analytics started getting into this columnar databases. Now there are open source variants of that. One of that is a Vertica, which is of course owned by HP. But that just gives you some idea how that space came into that. And what's happening is, in the big data field and the HPC, as I said, they are converging into this. You might do some analysis, modeling and something, but all these enterprises have done huge investments in the front-end tools, like the business objects or this, other visualization tools. They understand only relational databases. So from an architecture perspective, a lot of companies are using big data technologies like Hadoop, but in the end, the results are brought back into a relational databases, whether it is columnar or row-wise, to do some more additional queries that the users are comfortable with. So that's how I see the flow of that.
So I think the question for the broader panel is, what instances do we have of those kinds of newer technologies overlapping with, requests for either specific types of architecture or systems in your experience?
Yeah, we're fundamentally obviously a hardware company, and when we get to the the analysis part of this whole big data equation, Dr. Go showed a code this morning of a mindset, but it's a very old code, and it's really not our forte. It's a code that we're bringing forward and starting to use a little bit more. But we found that we've had to form relationships with third parties to be able to do some of these things. And one very recent one that we've just gotten off the ground is with a company called MarkLogic, and many of the names that you mentioned I'm not familiar with, and MarkLogic I had not heard of until we started to work with them. But once we got together, it was clear that we were speaking different languages. The MarkLogic organization was fundamentally ex-Oracle, so they spoke the database language. It was like a foreign language to us. But then we actually got that first sale. It was a very kludgy one for one of the Northern Virginia companies. And the interesting thing about it is that it was several $100,000, but the hardware part was only about 5%. So as we get into this big data space, we're starting to realize that being a hardware OEM is not necessarily what this is all about. It's a lot of the tools that you're going to have to integrate into what you're offering to really make you successful there. So I think we'll see a lot more of that at these kinds of conferences.
Yeah. So to take advantage of the emergence of big data as an opportunity to drive the HPC sales, true HPC sales, sounds like there's a lot of integration of or multiple language skills that need to emerge. Stephen, does that change a lot in terms of? You're the only guy in the room that actually knows the future, as far as I know. He's got a chart. So does sort of the overlapping of those two Venn diagrams, or those capabilities between the language of data management and the language of parallelism and high performance, do they perturb the course or change the course of architecture in some way?
I think that one of the additional confluences you see happening there is the interest in power management. And that power management is going to drive change on both sides. And we saw some talk about the power management of just how much it costs to just maintain the data spinning. And so what do you do? How do you stop that? But you also have the cost of data transmission and so on. And so we certainly have seen the reductions of how much the query would do and whatnot. But in the end, there's going to be, I believe, a much tighter, if you will, a data flow-like architecture coming back to us, that it will be enabled by emerging technologies, the things we see in the future, yes, of what it would mean to have substantial amount of storage very close on a switched fabric to a very capable processing complex, whether it be loosely coupled processing complex for not so much what we would call HPC or supercomputing, or very significantly tightly coupled system for more towards that supercomputing space, but that substantial amount of integrated memory and processing. It's the day of processor and memory, or memory and processor. We're going to be talking about processors embedded in storage, as the system. So yes, the architectures are going to come together. We're going to see changes on both sides as to how to manage, performance and power in that, and it's not that far away.
If I were to pull two words out of that, it's very close. That's the drum beat that I think the first person I met 4 or 5 years ago that was using forklifts to move data, that had to take the whole cabinet and get it onto a truck and move it. And somebody whispered in my ear today that they're still using terabyte hard drives to ship around. I think the big industry change we see or been investing in, I think somebody mentioned remote visualization with NICE over in Europe. Well, this side of the pond, we've been working on that for years at Altair, and it's that same concept. Let the engineer work where they work. Let the data be right next to the computing resource. Avoid some of that hops. And what was the number we had tossed out today? $100,000 to just make 2 hops with some large petabyte. Was that Dr. Go again that made that point? yeah, 6-digit numbers to save that ROI is pretty quick.
Sanjay, do you want to talk about the proximity of the importance of the proximity of data to the processor and what that means? And I'm trying to visualize. And when I was a kid, you'd see these artist conceptions of what a creature would look like if he lived in really heavy gravity environment, and be very low to the ground, very muscular, look very different from us. So, what does a system start to look like a few years out that's really tailored to truly a big data environment?
Yeah, so something near term, we have been working with Intel to come up with SL series lines, which is having a common chassis but different servers at the same time, significant amount of hard drives in each server. And why is the case? Because in moving data, as you heard the other folks also say on the panel, is expensive. So why not move the data closer to the processor, right? So that's a fundamental principle in the parallel distributed program. So what we have done is we have put 3 servers in one chassis. What that does is it saves significant amount of power. It saves significant amount of rack space, because these clusters we have seen companies like eBay, they have gone to 5,000 nodes and they keep growing. So the space becomes a real issue. There are real problems in downtown Manhattan where customers cannot put a new server into the data center. So they are looking at this solution. So if you see the recent announcement from HP and Intel commonly is that where we are going is a system on chip. Now what that does is actually imagine today you can put about 40 servers with some power and all that in one 42U rack, 1U rack. You imagine keeping 1,600 servers, and this is reality. Right now, the processor that is being used is the same processor that you're using in your cell phone. Intel has an equivalent one that is coming up in another 6 months' time, where the power of that processor suddenly goes up by 20 times. And this is only 6 months away. So now, suddenly, the power issue gets very, very resolved. At the same time, the space and the cooling accompanied by that goes down. And you will have storage blades, and we'll have storage and the system on chip attached to that. And that's how I see the big data architecture evolving.
Further comment to that? Rene, let me ask you something. I mean, you're selling to the federal government all the time. You've been doing this for a long time. You've got environments that have always been what might be, certainly you can define them as huge data sets, maybe now as big data in the other sense. You got intelligence and sensors streaming data, and a lot of it's traditionally wound up on tape. It's wound up, in storage. Have you detected any that you can talk about, any new sort of patterns toward the notion of big data with all this stored data that would affect the way they purchase systems or want systems designed at this point?
Maybe just 2 comments. One kind of an open comment. And we are seeing more procurements that actually have a data component and a compute component associated with it. I think there's a large NSF procurement on the street now. It's in a couple of different parts, but there is a data part to it, and there's a compute part to it, and we're seeing it in other areas as well. On the classified side, we're seeing more of an interest in NRE, more of an interest in building it their way, more of an interest in kind of the Burger King approach. You want to have it the way you want to have it. So we've been approached by a couple of the organizations to do some things for them. And I'm not a computer architect, but I think if you looked at it, part of their motivation is to try to make sure that they can solve their big data problem by having a small company create something that's a little unique just just for them, and that's picked up in the last couple of years. Maybe 2 or 3 years ago, we weren't seeing that kind of activity. Now it's coming from multiple locations. So maybe those two examples would suggest that, yeah, it is starting to happen.
And Devin, any comments on that in the visualization space? You had talked about people being remote from the systems, but being able to see into the system where the data was adjacent rather than moving the data around. Have things begun to change in terms of the way people are specifying systems or talking about data in a significant way in visualization?
Yes, there's a hunger out there. My first thought was Altair drinks its own champagne with about 600 engineers who are either on site at a customer doing these large analysis like David Bowen, or but the story I want to tell is of a grizzled engineer that I met just last May, who for 30 years had been using the machine under his desk. And those HPC resources out there, even though they've been available for many years, he's never gone there, just perceived as too hard or whatever, but saw a demonstration of this and actually working, and he stuck around late to tell us, 50, 60 people. He waited till everyone was gone and told us, I may have to change. And he has. In fact, we've been offering a web-based remote access tool since the year 2002. We built it for ourselves in-house around 2000 and then started selling it. And now we're offering that, been offering it wider, a third-generation product now. And this third generation has more than 10x usage than its predecessor. There's a hunger. There really is. I see a big shift that way.
Sanjay, I don't know if you are prepared to address this. I'm sorry to spring it on you, but there's a discussion that's going on about analyzing big data as it comes through the stream, sort of as it's streaming or in memory, and doing things a little bit differently. How do we think about that?
Yeah, I mean, you have heard through the presentation also that the big data framework using Hadoop and those type of technologies batch oriented, right? It's extremely slow. There are some open source projects out there, and if you see the SGI presentation from this morning, you know how the larger problems need more denser architectures. What they are doing is they are building in-memory query engines. So there is a query engine called Impala. It's an open source version adopted by Cloudera, which is one of the premier Hadoop distribution. And what they are doing is they are building a parallel query database, but which is in memory. So even though the data exists on HDFS or the Hadoop file system, they will cache that, and eventually you'll be able to get some real-time access based on that. It's out there. It's still in its infancy, but you can see in another year's time this technology evolving. There are already 4 or 5 startups there in this area as well.
Other comments on this general area? No. So when we look at the other side of the coin, which is the skill sets, we always have this double-edged problem in HPC, which is trying to figure out how to build the next generation of skill sets, where the people are going to come from, whether the model is going to be legitimate, whether it's MPI or something else, and be replaced, whether or not a younger generation is going to respond to that. What are the various different gaps in terms of the skill set that people need to deal with HPC and big data? I mean, how does it change? I mean, how does it change the the set of requirements, it expands them again. What are we looking for?
So let me address this first from a big data perspective and let the others comment from an HPC perspective. I was hearing John West's session yesterday and how difficult it is to recruit people in the HPC area, and they lack the expertise necessary. And one of the fundamental challenges that I have is the parallel programming expertise. And if you go on the big data side and look at the Hadoop, you still have to program in a MapReduce programming framework. It's extremely hard to find the resources there too. So what's happening is there are tools being evolved which hide the complexity of parallel programming. So for example, there is a tool called Hive, and what that does is it allows you to program SQL. If you know SQL from the database area, you just write a program. Now behind the framework, Hive is actually looking at the metadata, where which node has what data, and is creating parallel tasks. And that makes it more simpler. So we need more of these sort of tools that hide the complexity to promote the big data. And that's sort of the resource gap that we see from the big data side.
Rene?
Maybe just a little bit of a tangent more about the people. This morning, England played a video of the Wikipedia and the connections between countries or whatever, and there was a comment that, some of those relationships were already known, which is true. But the guy that did that, it was a guy named Caleb, I think it's Laterou, who came from the University of Illinois, and he's now somewhere in the D.C. area working with an agency looking for other meaningful relationships. But the interesting thing about Caleb is that he was not part of NCSA. He was actually working on his doctorate in library science, and I think he was in his late 20s or early 30s, and he'd grown up in Champaign-Urbana, and his father had actually worked at NCSA in the seismic area. So as a high school student, he was able to go over to NCSA and dabble in the computers and learned how to program, and shared memory was nothing that was new to him. So later in life, when it came time to do his own research and his own experiments, he felt very comfortable doing that. But as I talk to a lot of our customers and some of the side conversations I've had here, there's a concern, number one, that there are not a lot of new people coming into this sort of generic HPC or big data space. At supercomputing, it's pretty much the same people that you see every year, a year older. And then for those that do come into that space, they're not thinking quite large enough. They're not thinking in terms of really solving large problems. And then, in 10 years, 15 years, those will be the people that are doing science policy out of Washington. And that's not much longer than, when we'll start to be deploying the exascale kinds of systems. So I think there is a bit of a famine, and it's been kind of an undercurrent for a few years. And sometimes, the best and brightest, go back to their native countries to practice as opposed to staying here. Sometimes they go into social networking or video game production or something like that. So I think it is a little bit of a gap that we're seeing now, and I think it needs to be addressed probably across the board of both the HPC companies and the big data companies to try to encourage people into this space, summer intern kinds of things, or, working with kids at a very young level to get them interested into the kinds of things that we'd like to see in the future.
Stephen, I know you want to get in, offer some time to Devin. If
my personal, mine's also personal skill, my comments related to what Rene is saying. It's actually gotten worse instead of better. We've always valued people with applications depth on top of systems familiarity and aptitude. So now it's actually getting down to the command line level to be able to hide all the complexities. So what do you have to do? You just have to have someone in HPC who's able to take an input deck or a script from a user and make it work, even if he's not an Abacus expert or OptiStruct or any tool of your choice, Flash, whatever it may be. Yeah, it's getting worse.
Dime a dozen, those people, right? Stephen?
There are many problems. When we talk of missing middle, we looked at the architectures we have today, the technologies, the software, and so on we have today are well suited, if you will, to more usage, but the skills of being able to apply that usage is perhaps the limiting factor, and not so much the skills to develop those tools. But in this particular conversation you're having here is the need for technology to become much more power aware and parallel aware simultaneously with communications aware is requiring a skill set that is being outstripped by the need for the technology and the actual ability to bring about that technology. It's, you know, the ability to design the processors, the storage, the fabrics, and so on, all to enable it. That low end area, okay, is moving along at a fast pace, perhaps not as fast as the need on the far side, but in the middle. You know, I like Kraft mac and cheese, but it's not as good as my wife's homemade, right? So if you're going to end up with a middle ground of majority of usage is using abstractions that cannot, and I'll go on record saying cannot deal with power performance efficiencies to the level of the skill sets of someone who's in tune to that. You know, all of the effort going into making these systems power aware, communication aware, and so on is going to be fretted away by applications being used at an abstract level that has lost that efficiency. And so sure, it's better than it would have been, but it's certainly not as good as it could be. And so I don't want to take the eye off the ball at all, that the basic skill sets of parallel and data management, data science, and so on is something that is, shame on this industry for allowing us to be lost to the Java programmers.
So you've insulted
just about everyone.
Yeah. Well, you were pretty kind to Kraft macaroni and cheese.
There you go.
Okay. That's good. So, in other words, you're saying there's hope.
I think I probably should stop.
Yeah, no, it's okay. All we need, as I understand it, is somebody who's highly skilled in parallelism, understands constructs like MPI, understands data and data parallelism, speaks the language of the data solutions providers, and has a very high security clearance. Yeah, dime a dozen. Okay. So,
but that's not impossible.
No, I know.
No, it's a matter of incentives and encouragements, and why do we lose the engineering skill sets in the high school level, the 7th grade level? Over in our work in Wheeling, we found that the actual turn down in population of women in engineering, for example, was at between the 6th and 7th grade. We were talking about high school programs. How can we get more going there? And they're explaining you lost them in the middle school. Okay, so when half the population is reduced by 90% at 6th grade, all right, so how do you go about engineering? Workforce development is something that needs to be paid great attention to and looked at all levels. Yeah. It's not impossible, but we might have to get rid of some of my other pet peeves about social engineering that goes against doing
That's
that.
Another panel.
There you go.
Which maybe people want to stay for, I'm not sure. So we've got 5 or 10 minutes left, and I wanted to just give you a chance to make any final comments, but one of the things I wanted to ask was, we talked about exascale, and we're always talking about the next level of architecture and the breakthroughs needed to get there at this meeting, usually anyway. So put it into context, in your opinion, for us, the ability to handle big data and for HPC to become an integral part of that. Is that as important as getting to another level of performance like exascale? Is it going to distract us from if I read the exascale report in 2 years, is the headline going to be money for big data development scraps exascale programs, or how is it relative to other developments that we might look at? How important is it?
Well,
Is this mic on?
It must be important. Here, my company is a software company, yet went out and kind of built our own data center. I mean, we have sold some of the cycles to some customers that needed it, but that's not the reason we built it. We're just proving that it can be done. We call it HyperWorks on Demand. So I think the short answer is yes, you need it. It's big. It's happening. Yeah. What's that?
It's as you're putting on an equal scale of importance to the next big breakthrough.
Yeah,
Maybe an unfair question.
It's one big enchilada.
It's what I do.
So I'm a big believer in free market enterprise, and the customer is always right. So, the ability to discern that what they're looking for and develop the products to go in that direction. If one particular area of interest is overshadowed by another by market forces, then that's what happens. But in the end, we have fortunately technologies that are at a focal point of, or having a common point of interest as to enabling, whether you go left or go right, you still need to have the locomotion to do that, and there's a lot of commonality there. That so if one gets delayed, it doesn't mean that it was greatly impeded, if you will.
And we call big data a buzzword earlier, but I think it's a buzzword that actually has something to it. There've been cloud and grid and utility computing and green computing. They're all kind of had their place, but big data seems to allow you to be going with a trend. You're kind of swimming with the tide, if you will, and therefore I think it's easier to get funding for that sort of thing right now than if you're trying to do something without it. And I think that'll pull along a lot of the HPC efforts.
Very good point.
Yeah. So, some comment on your earlier question. I would encourage everybody to read a Harvard Business Review article on what is the sexiest job of 21st century. And that's called data scientist, and that gives you a lot of skills that are needed to survive in the big data area, and mostly it's statistics and some of the management training, in addition to some of the computer architecture inside. So it's sort of a variety of skills that make you up as a data scientist. So and then coming back to this exascale thing, the architectures, if you see today, it's with the existing technologies, you're not going to be able to build the exascale computer. So the fundamental thing is the parallel programming has initially the coordination and then finally the aggregation stage. So all the resources cannot be used during the final phases because there's a lot of traffic going on the interconnect. The interconnect, even if you use InfiniBand, there's a limit at which the electrons can move. So you have to think in a different way, this problem. And people are solving this in the labs, but you will see it's still quite a bit away. Instead of moving electrons, why not move the material? And that's where the nanotechnology is going to come into play. And the architectures, instead of building a cluster, think about something else, like a mesh architecture or something, because you have to drive down these communication paths really to a tiny amount in order to do the scaling up. So there are some challenges in the existing technologies to even go to that level.
Stephen, what month will we have that mesh architecture? Do you know?
I don't know, but I will say that that earlier I didn't mean to say that it's one or the other. I don't think we'll be seeing that. And so I think that both will be able to go down the technology development paths and coexist quite well. You know, John, one of the things that we might be interested in is, you know, about 10, 11 years ago, there were, you know, big data was at least mentioned in the sense of, you know, the story goes that Walmart would be able to see a cold or a flu or whatever marching across the nation and would be able to logistically stock in front of that front, you know, their own little micro weather front. And that's an old story. And so people that have been doing that kind of thing and predictive logistics have been doing something that we're seeing becoming, if you will, their own missing middle of data management that is becoming this big data phenomenon, at least of the big data as we know it now. But you know, others have been doing that in their own silos and for their own differentiation. And so, you know, seeing that kind of, you know, the pioneer's perspective on that might be of interest for us to see next year.
Yes, well, it's certainly going to be interesting to see the way the definition of big data is pulled apart into its component pieces as people begin to think of it differently. And I know that the level is at the level of hype is it might be at its peak, because I was in a coffee shop in Harpswell, Maine, which is a very small fishing village in Maine, and these two guys who are lobster fishermen were talking about big data. He didn't mention Hadoop. That would have freaked me out. But if any of you would like to make a closing statement, or shall I take questions first? Let me take some questions. We have a few minutes. Any questions? No? Well, I'll just let you make some closing comments, but let me just say this was, you know, a kind of a diverse and a loose conversation about a lot of different topics with people with different approaches and skill sets, and I thank you for indulging me in going down some roads that were a little different, and I really appreciate it. Before closing comments, can we have a hand for the patience of this panel? And I'll let you guys close.
Bob and John, certainly appreciate the opportunity to share, you know, open thoughts about this phenomenon that we're seeing, and I look forward to continuing in this very personal environment of the Newport HPCC event. That it's been a long tradition, and I look forward to it having an even longer tradition. So encourage those to spread the word. This is where the good conversations take place. So thank you.
Thank you, Bob. And again, thanks for the opportunity to participate in this panel discussion. My background is traditionally databases and not that much conversant with HPC. So the last 2 days has been really good. I'm beginning to get some slight insight into the HPC area. That has been really great. Thank you.
And my thanks as well for allowing us to come. When we talk about exascale and, you know, 2022 and being on the sales side, our time horizons are a little more modest. So we think in terms of the current year, the current quarter, which ends on Friday, as my boss reminds me all the time. But because of big data, before this coming Friday, we're going to actually ship a small system to the Treasury Department. And that's something we never would have done before, but for the advent of big data. So we're excited about this marketplace and look forward to coming back and maybe sharing some of the successes with you.
No offense, but I hope that isn't up and running before my taxes are filed. So.
I see where you're headed with that. I can't say thanks enough. I totally agree that right here in Rhode Island, it's a lot of valuable conversations. Commute versus compute is a term I've heard for a long time, which seems completely relevant here. And scheduling your choices wisely so that just as we've heard many times, have that data close to the hardware and save yourself a lot of time and money, and bring it on.
Thank you ever so much.